2019, we decided to go the web application route just to kind of leverage off the current skills that we currently have. Sean, he's already a front-end developer. And Sanjay, he is database. I'm also full stack, as well as two other of our other team members that couldn't be here, they're full stack and database as well. So again, we did a web application using TensorFlow.js, which is built on Python library. So what they did was they just took all the Python code and converted it to JavaScript for the browser. For the browser.
I love the graphics, by the way.
Oh, thank you.
Yeah.
And so we use TensorFlow.js, brings it to the web. And so what I will do, I'll kind of go over like just the web application part of it, and then Krushan will speak more on the model, because that's what he breaks down. So you want to talk? You wanna go ahead?
I think you can log in first and then not talk about it. So I think before or after she logs in, I think the main takeaway is we didn't actually have an experience with machine learning technology. This was the first time that we actually tried to implement this. And we actually went through quite a few obstacles. But that I think also took some time in getting resolved, and we just had to ask a bunch of people, like, hey, how do we do this? So that's really nice.
So basically, we leveraged off of Sean's team. We took his model in Python and we converted it into JavaScript, which is a two-step process using a JavaScript converter. And so
and this is right here, the sign-in page is actually connected to the Firebase. So if you have a wrong password, it will basically wouldn't let you log in. And also, this site actually is hosted on Firebase as well. So that URL right now, if you go into it from your phone, it will actually work. But I mean, I will actually talk about it, why the prediction does not work. But yeah, so I mean, the site itself is hosted online. So while we are having technical difficulties, let me just go through our process. First, we actually, solution was to get all the data from Google or whatever source we had. At that time, what we actually thought was Extron will actually provide us many data or images for using our model, but that was not the case. And also the images that we got from Google was not exactly quality. And while you are doing a machine learning model, the images has to be quality and diverse, as Kyle said. So that also, even if you do Google search right now and then just try to find two different towing aircraft nose gear or something, you will see that some of it are basically the same thing, even for different aircraft. So we cannot rely on Google that well. So what we did to get it working was basically get Emmanuel's team model that they already had trained. So they had trained in Keras, that's another library, I think, Python library for machine learning. So once we got that, we actually converted it to JavaScript TensorFlow, which would let us run on the client side instead of having it on the back end. So here, it's actually running it on the web application itself and not on the server. So that is a big advantage if you are actually not connected to the internet. So it will basically run it on the background, and then since the already has a model, it will also classify the images that we provide. So I think we have it running now, so let me. Okay, so. Okay, good.
Yeah, so our model, we did our main was model, they did theirs off of, car tires, cause again, we didn't have like the sufficient data set. So-
Well, car tires,
Or-
bicycle and motorcycle tires, so three different types of tire, which is similar to the problem that we had, but it's not quite the same. I think once you, no, okay. So once you capture the thing. So now here, it will show you what is going to capture, and then right now it's trying to predict like what this image might be. Then here it will say, okay, so the predictions are this, and the top prediction is basically this is the probability of it, a confidence level that you will say. So here, as you can see, it's 0.999 or something, which means basically 99% accurate, which is pretty good. And also it will say the other probabilities as well. I think we can show one more. Now this is a bicycle tire. And now the same thing will happen if we go here, and it will update the. So now as you can see, it's basically perfect. One, you cannot go more than one. So it basically says the bicycle tire is the most accurate one. Then if you come here, then the operator or whoever is using this application will click on save and proceed. So now here it will tell you confirm it. Is it actually a bicycle tire or whatever the category might be, A, B, C, D, E or something? Then
We get to say. So if the operator's, happy with this decision, they can continue to save changes, and then it will save it to the database, and, prompt you to that application is ready to be in process. Or if they, if the operator decides that this is an error, they can, click on report error, and it will redirect them to the report error page, and they can fill it out. Or this can be actually pre-filled, by whatever user decides, signs in. So that was, it went over to a motorcycle. Right. And then it will pre-populate the image of the current transaction, and this, empty input box that can, describe what's going on. And then this is where we will, get a manager to approve the report.
and this is also connected to the database as well. So if you enter your wrong password or something other than the current password that's on the database, then it will basically tell you it's invalid. Now it will say the override is successful.
Right. And then once you submit, it goes back to the scan screen for the next transaction. And so the operator can also have the choice to, view all the logs here. And of course, this is customizable, so you can put like any information you like that you would wanna, view in the table. You can look at all the successful records or failed records here, and you can also view like all the, users that logged in.
I mean,
Oh, and so, now, so during our implementation sprint, there was a concern that was raised that, that pushback tractors did not have Wi-Fi connectivity, so we decided to try to delve into territory to convert it to a web application, or a progressive web application. And what that is a hybrid between a traditional web application and a native application. So you have all the full features of a native application and as well as a web application. We didn't quite get to configuring it because of time constraints, but the technology is there. So if you have the devices at a docking station where there's connectivity, will update all the information, and then once the operators take it out of the tarmac, they can still use it offline, even with the auto prediction and get storing like the manager's password so they can get an approval if there's a report that needs to be saved.
So would you run that in like Windows Explorer or?
So right now, because it is a newer technology, Chrome does have, it supports it fully, but in Explorer, they're still coming on the bandwagon. Every other browsers are still, it's in development mode to support the technology.
Yeah, this TensorFlow.js is fairly new, maybe less than a year old, so that in itself has some issues with it. So what I would like to get it done with is, so for mobile, the application is working. The only thing that is not working is the actual prediction. Why? Because it's, I think what happens is, in the mobile, it's looking for WebGL, that's a web technology that runs the graphics and everything on top of it. But what happens in mobile is, I think what the texture size or something gets increased to the point that it cannot predict. But as you can see here, here for web it's fine. For this desktop it's fine, but mobile it does not predict right now. And also the advantages of using TensorFlow.js is, instead of running on GPU, it's running on CPU. So even if you don't have a GPU, let's say NVIDIA is not there or something is not there, you still can run this model on top of it because it's running on CPU. I think that's one of the big advantages of using TensorFlow.js. So that's pretty cool.
When you pair it up with a progressive web application, you have the benefits of like once you write it one time, it runs everywhere. So you don't have to like write for mobile or web or any other system. So as long as the device has like an internet connection, you can download it and you're good to go.
Do you guys measure the time difference or the efficiency of a web service like this one as opposed to a dedicated program like the ones that first being presented? Is there like a big difference in the performance?
There is a slight difference in performance, but it's nothing where you sacrifice accuracy.
Like you said, the neural training will take place once you have Wi-Fi connectivity, right? So you take the pictures, it's approved, and if you don't have Wi-Fi connectivity, when you upload the picture, the neural engine trains it and deploys back to the web service.
Yeah, that definitely can be implemented. So yeah, if there are new training data, then yeah, you can take those photos and once it gets to Wi-Fi connectivity, you can use something like a Google compute engine and you can trigger it off and retrain the model.
All the pictures in your examples have been, side view, nicely cropped. Does this work at other angles? Maybe not so nice. Because the operators are just gonna go walk up and
So it's kind of like back to what I was saying. Well, for our model, I just still want to you still. I know my phone doesn't.
But yeah, it kind of does it.
So I guess it depends on your training data.
Yeah,
If it's
so
anything
for this
different,
model, they had to take like thousands of images images of each category.
Okay.
So bicycle tires, they just Google search it and then get all the images from it. So the more the merrier, I guess. I mean, that's the case for all the neural networks that we actually found out afterwards. So yeah.
So as far as the images that we provided, what's, I guess, some feedback on how we can get better images and, that'll, I guess, be more useful in training these models?
I think the best, the images that you provided were great, but there just weren't enough of them. So we need like, at least about 100 photos from each aircraft. So the best way to do it probably would be like what suggests is put a camera on the back of the devices and over the course of maybe a few weeks, just capture video, maybe just capture video, we can take frames from those videos, just so we have specific data that sees exactly what the camera's gonna see, and that we can train the model more accurately. So right now we're just kind of grabbing images of plain tires and tires from the internet, and they could be mislabeled, they could be from different angles, they could be different sides. There is no guarantee of that. So the only guarantee that we're gonna get quality training data is to collect the images ourselves over a course of time, that with the point of view of how the camera's gonna see it.
Gotcha. So I guess from the videos that you guys received, is it not enough to like splice, I guess, every like 5 seconds or something like that?
Yeah,
Change up?
Dr. Randall's not here, but he uploaded the photos. I guess he tried to upload the videos and they didn't upload correctly, so we couldn't view them. And we emailed him about that, but we didn't hear anything back. So videos, unfortunately, we weren't able to use.
Okay, so would that have worked though, if you, cause in
Yeah,
the videos
yeah.
we did like 360 walk arounds at like a very slow pace. And everything.
Exactly, yeah, if that could maybe work. The only thing is, we still want to collect training data because the training data over time, because when you're collecting that video, it's still in the same environment. So
Gotcha.
if it's sunny, it's all gonna be sunny. What about cloudy? What about snow? What about rain? So if we collect the data over time, we're gonna get the same tires, but we're gonna get them in different environments and different circumstances that will help train the model more accurately.
Okay, makes sense.
Yeah,
You guys could have reached out to me after I sent you the link to the,
Yeah.
to the videos. Sorry about that.
No worries.
Uh-huh.
Yeah, when it's training through the model, there's these layers of computations that processes these images. Basically, it does this matrix calculation where it takes the height by width of the image and then brings it into a flattened vector, right? And so, what it'll do is it'll crunch through that data through all these various levels looking for patterns. And so that's why you need a diverse set of the images on one thing with the correct label on it, so that it's looking for patterns that remain the same. So that's how it knows. So the problem could be is you don't have enough images, or you only collect them in one environment. Well, it might be looking at a particular pattern it sees that might be irrelevant to what you're actually trying to classify.
Like something in the background, like a car that's parked in the corner.
So that's why you need a very kind of diverse set of weather conditions and environments, all targeting the one thing you want to predict.
Okay.
To make sure that you overcome anything like, say, it's looking for the sun instead of the actual thing.
Makes sense.
Also, one of the solutions that our team actually had was to actually get the N number from the TL, and then just use the N number and search it through a database and find out the airplane model.
It's actually required to have it on the back of the tail. As well, we also saw from the sample data that, there's like numbers on the belly.
Exactly.
It
Yeah.
kind of like fit right into the category, so that's another consideration.
Yeah, then if that's the case, then the machine learning.
That's easy to get like text.
Letters.
And left to
Yeah.
train, so.
That was a cool
Like
idea.
the same.
Yeah, that's one of the possibilities.
Good job.
Yeah, thank you.